third grade. Today we are taking measurements of length to the nearest 1/2 and 1/4 inch, and we're going to put that data into a line plot. We are completing page 596, starting with number 5. And here is our answer for number 5. Take a minute and pause the video. Keep listening if you need some help with this. In order to arrive at the answer to number 5, you really needed to understand the problem and what was happening. Our book already measured all of Tara's magnets for us, and they recorded all of the magnets over here. So picture this for a minute. You have a magnet in front of you, you measure it to the nearest inch, you record that nearest inch, and then you put an X over the measurement up here in the line plot. Tara did this for each of her magnets. She measured, she put a mark to show the number of inches. So that's the first thing that we needed to understand, that they've already measured, here are the lengths. The question we are focusing on is right here. Are more magnets longer than 2.5 inches or shorter than 2.5 inches? Let's take a minute and talk about that. If we're looking for magnets longer than 2.5 inches, that does not include 2.5, because is 2.5 longer than 2.5? No, it is 2.5. So we want everything greater than 2.5. So 2.5 is here. Remember, that is not included in either of these, shorter than or longer than. So for longer than 2.5, I am looking over here. This is longer than 2.5. So remember, these numbers are the lengths. These are inches. So this means right here, this is 3 inches, and there were 1, 2, 3, 4 magnets that were 3 inches. There was one that was 3.5 inches, and there were 2 that were 4 inches. So that means all of these together are longer than 2.5. So this is 4 plus 1 plus 2, that is 7. There are 7 magnets that are longer than 2.5. Now let's figure out how many magnets are shorter than 2.5. Remember, if we're looking for the number of magnets shorter than 2.5, does that include 2.5? Is 2.5 shorter than 2.5? No, 2.5 is 2.5. So whenever we are figuring this out, just like when we were calculating the number of magnets that were longer, we are not going to include 2.5, because 2.5 is not shorter than 2.5. So whenever I look at my line plot, I see this 2 stands for 2 inches. There were 3 magnets that were 2 inches. There were 2 magnets that were 1.5 inches, and there was 1 magnet that was 1 inch. So altogether, there were 6 magnets that were shorter. Okay, now take a minute and reread the question. Are more magnets longer than 2.5 inches or shorter than 2.5 inches? We'll take a look. There are more that are longer. So there's our answer, longer than 2.5 inches, because, don't forget this explaining part right there. When it says explain, you better be writing because. Because 7 are longer than 2.5 inches. 6 magnets are shorter than 2.5 inches. 7 is greater than 6. Number 6 was done in the Math on the Spot video, so if you missed that, go ahead and scan the QR code in your book and complete this problem with Professor Berger. Moving along to number 7, here is our answer, so please pause the video and compare yours to mine. Keep on listening if you need some help. Okay, now I know it's been some time since our data chapter, and we haven't seen many line plots since then, so you might be a little rusty here. So let's review line plots and how they are set up. So first of all, when we're making a line plot, we always want to start at the lowest data point that was collected. So here in our line plot, we were collecting length in inches. So Tara's shortest magnet was 1 inch. She's going to start at 1. So that kind of answers the first part of our question. We wanted to start at 1 because they are all at least 1 inch. There were no other magnets that were shorter than 1 inch. So she started here at 1. She stopped at 4 because no magnets were greater than 4. When we are doing a line plot, we always start with your least number, end with your greatest number, and you want to go in order from least to greatest. We never want to skip any numbers or leave any out. If any numbers received 0, so in this case, if Tara did not have any magnets, let's say, that were 3.5 inches, there would just not be an X right there. Now we know she had 1, but let's just pretend if she had 0, there would be no X's. So we never want to leave any numbers out along the bottom. So that's our answer. She started at 1 because no magnets were less than that, and she stopped at 4 because none of her magnets were longer than that. Our last problem is number 8. The answer is 3.5 inches. Pause the video and compare your explanation to mine. So unfortunately, there's no way for me to display a ruler on the screen in this video right now. So you are really going to have to listen to my voice, watch where I am pointing on the screen in order to figure out where we get this answer. So if you need some help with this, listen to my voice right now. So first, you need to pick up your ruler, and you are going to measure the pencil in your book, not on the screen, in your book. When you pick up your pencil, you're going to look at the inch side, not centimeters, inches, because it says in the directions that we want the nearest 1/2 inch. So we're using inches. You are going to put the end of your ruler right here. So whenever I say the end of your ruler, I'm talking about the end that is closer to 1. Not the other end of the ruler. I believe your rulers go to 4 inches, perhaps. I could be wrong, but you're not looking at the 4-inch side. You're looking towards 1. So you put it right there, and the first line on your ruler should line up with this dotted line right here. To find our measurement, we're going to look at this end of the ruler, and we are going to look down at the mark on the ruler. So you should see that this mark right here is between 3 inches and 4 inches. If you are using the box in trick that we learned earlier this week, you may circle the 3, circle the 4, box those two numbers in, and divide it in half. Since we are measuring to the nearest 1/2 inch, we want halves. So make a bar or a box that is enclosing the 3 and the 4, and find the halfway line, trace it down. So it looks like we have a little mini fraction bar. You should see that this line, the eraser side of the pencil, hits almost halfway between the 3 and the 4. That means it's 3 whole inches, because this whole section of the pencil over here is 3 whole inches, and then this over here is 1/2. So there's our answer, 3 1/2. Definitely use that box in trick if it helps you. All right, my friends, Awesome job today. You may look up on the board for your next activity.